Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. So I welcome you all to this platform. So again, I welcome you all to this session of casting part 10, and in this session we are going to do the lot of things. We are going to see some of the miscellaneous parts that we have left in this casting chapter, as well as we are going to see some of the previous year questions and some critical questions, and we are going to analyze those questions, how to deal these things. So again, I welcome you all. So this is a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research paper publications. I have also presented a lot of papers in international uh, journals and of national and international journal of repute. So if you have a keen interest, you can always go and check out my journals, and you can follow me at unacademy.com at the rate of v.ksir. Here at the Unacademy app, I'm teaching the strength of material, so you can follow me, and whenever I will post a new course or a new video, you will be getting notified. Although I'm teaching here the strength of material, and that is also in a full-fledged. So this is the casting part 10 that we are going to deal here. So you can download the Unacademy Learning app, because at the Unacademy Learning app there is a benefit that you can attend the free live classes. So free live classes you can attend, that is known as special classes. That is known as special classes, and these classes are free. You just have to enroll into this course, and after that, here I am teaching the strength of material, so you can follow me there and study the strength of material. As well as there is another thing is there. Here there is a plus subscription. So if you are going for a plus subscription, then you can attend the live classes of almost all everything, all the lectures, everything of the every subjects. So these are the benefits are like daily live classes are there. I have already told you. Courses are structured in manner. Live tests and quizzes you can give, as well as the unlimited access of the course content, doubts, and whatever the things you can resolve at the same moment, as well as there is a dedicated doubt clearing sessions are also there. Courses are very structured in manner. You can attempt test quizzes, a lot of mock tests, practice tests, and all these things are unlimited, so you can access this course content unlimited times. As well as there is an iconic subscription. In this iconic subscription, there is a benefit that you can choose a personal coach. And this personal coach will help you throughout your preparation of GATE and ESE. There is another feature here is study tracker. Study tracker tracks the study performance, where you are lagging, where you should improve, where you should work out, and these things are given as a detailed report here, so that your performance should enhance, it would boost. And believe me, this study tracker is very good, it will boost your performance. So apart from the plus benefits, you are getting these everything: personal coach, these things, study tracker, means question and answer practice, a lot of things are there. So these things are there, so you can go for the iconic subscription also. And these are the top educators of the Unacademy. And Unacademy has a lot of branches and the batches for the GATE and ESE, for the mechanical, civil, electrical, electronics, production, instrumentation, industrial, chemical, everything. And one more thing that I want to announce here, that these cost for the plus subscription, what you can see here, 5,000, 12,500, 20,000 and 25,000. These every cost, each and every cost is going to increase. There is a increment in the cost. So if you are interested, then you can go for the plus subscription, because eventually after some time the cost is going to increase. So you will not be getting these 25,000 of the package in 22,500, even if you will use my code. So the cost will increase. Hence, if you are interested to purchase, if you are planning, that you're thinking that okay, I should purchase it, and you are in dilemma, I should aware about it, as the price is going to increase. So for a 12 months, it is cost around 25,000. And if you will use my code SIRVK, SIRVK, then you will get a 10% off, and the discounted amount would be 22,500. So similarly, for 24 months, it would cost around 30,000, and the cost is, if you will use my code SIRVK, then the discounted amount would be 27,000. So you will get a 10% off if you will use my code SIRVK, SIRVK. And apart from the 10% discount that you will be getting, I will provide a mentorship throughout your preparations. So one most important thing, prices are going to be increased. So if you are interested, if you are planning for that, if you are thinking like that, you should go and purchase as soon as possible. And if you are going it, use my code SIRVK, SIRVK. So you can go for 6 months plan also, 12 months plan also, and for a 24 months plan also. Any plans which suit your pocket, you can go for it. Good evening, everyone. Good evening. शुभम राज, आज जो है टुडे कास्टिंग टेक्निक्स विल ओवर. Today is the last class of casting, and what I can say you, I have already conveyed these things to the team, but I am again telling you, if there is a delay in providing the PDF, go and take the screenshot of the uh, slides, and you can easily make the PDF. So I have already talked with the team, so let them what they want to do. Sir, after 11 there was any class? No, Asis, I haven't take any class, because that app was not giving me permission to take another class for the today. Okay, so I wanted to take the class, but I couldn't. Okay. Okay. Okay, so again I welcome you all to this session of the casting that we are going to do, and this is going to be our last session of the casting. We are going to do the tata bye bye to this casting chapter. Okay, so let us do the needful, that are the things that has been left to this things. Okay, so we have seen that we can produce the casting. We have seen a lot of processes that how we can produce the casting. We have already seen that producing the casting, what are the things needed, what are the tools that are needed, how we can create the patterns, and in that patterns what are the allowances are needed. We have seen a lot of things like that. So what happens once the pouring of metal is done, casting solidifies. After that, what you want, you are breaking the molds, right? So somewhat like you are breaking the mold and taking out the casting. What happens in that casting? So let me write it here. What happens? So suppose that this is the metal, this is the casting metal that you got. Okay, and in this casting metal, suppose that you have uh, sand particles which is attached to it. So these are the sand particles or the mold particles. Okay, mold particles. So like mold particles are attached throughout the casting, right? Like this, mold particles are like this. Let me change the color. So mold particles are like this, mold particles are like this through the entire, it is like stick to the entire casting. Now, how do I remove these mold particles from the casting surfaces? How we can remove it? So there is a process, and hence this is the section that we are going to study, that is known as cleaning cleaning of casting. Okay, so cleaning of casting, how we are going to clean these casting whatever we have produced now. So how we will going to clean those things? So first process is known as fettling. What is this fettling? There is a fettling machine which is which looks like this. Okay, so something like that. Okay, so this is like this. So there is a machine like this, and this machine actually rotates, like this is rotating, and this is rotating as well as this is vibrating. So what happens that on the surface of this casting, suppose that on the surface of this casting, what you do, you just put this fettling machine over there, and it is rotating, this fettling machine is rotating and this is vibrating. So with the help of the vibrating mechanisms which is here in this, so this is actually removed, those all the particles of sand, those things are removed, right? So see here, so this is the so in this way you are actually removing the mold particles. Okay, so fettling is, it is a process of breaking the mold by providing the vibrating mechanisms. Okay, vibrating mechanism means what, like this. Okay, so with the help of a vibrating mechanism, so with the help of the vibrating mechanisms, what you are doing, you are actually removing these particles. Okay, so this is the fettling process. Next process is this, that is known as short short blasting or sand blasting. So what is happening in this short blasting and the sand blasting? Suppose that you have a casting. Okay, so this is your casting, and after the casting has been prepared, you got like this. So you are getting, suppose suppose that these are the silica. Okay, so let me change it here. Suppose this is the silica particles. Okay, silica sand is there. So what is happening that on the surface of the casting, these silica particles are actually there. Okay, so these silica particles are actually there. So how to remove these silica particles? Somehow that these fettling process is not enough to remove these silica particles, and hence, because see, these are fused, these are very much fused with the casting, and hence how to remove these silica sand? Okay, the silica sand, how to remove the silica sand? So there's a process of blasting the shot, right? So what is this shot? There is a shot is that steel balls. What you do, you are using the steel balls like this, and these steel balls, you are using the steel balls and throwing here throwing here with the very high velocity. Okay, very high velocity, you are throwing the steel balls in this entire casting. Okay, so what happens, since these steel balls are of very high velocity, so due to this high velocity, they provide the very high impact on these casting surfaces, and hence these silica sand get removed, right? So you will be getting the things like that, suppose like that. Okay, so suppose after the after using the steel balls, that is the steel balls are known as shot. So after blasting the shot, what happens? This silica sand will get removed, and hence you will be getting these kind of casting. So after getting these kind of casting, what you will do, you will machine these parts, you will machine these parts, and you will machine these things from the entire way, and hence you will get a very nice casting after that, like this. So this, in this way, you are actually cleaning the castings. So this is how we are actually cleaning the castings. Okay, so this is how we are cleaning the castings. So basically I should write here to remove the silica sand particles which are fused on the surface of the casting. Steel balls. Okay, so we are using the steel balls, you have seen. So steel balls will be forced on the surface of the casting. Okay, and this whole process is known as shot blasting or sand blasting. So if you are using a sand, uh that is known as sand blasting. So I hope this is clear to you. Okay, I have a doubt. Less aspiration leads to more erosion. How? Why you don't ask these things at that time? Because I am teaching the casting. Okay, no problem, I will tell you at the last. Okay, Subham, I will tell you at the end. I will tell you, clear your doubts. Okay, let me teach now. As of now, let me teach. So if you have any doubt from these things that I have taught you right now, then you can ask me so that I can clear your doubts at the same moment. Okay, at the same moment. So this is all about the cleaning of casting. So how you are cleaning the castings and how you are getting the things. Okay, now let us move to our last topic, very last topic of your casting, that is known as casting defects. Okay, that is known as casting defect. If you have any doubt till now what I have taught you, I will clear your doubt as now. Please ask me questions what I have taught you now. If you have any doubt, and I have already told you, Subham, I will clear your doubt at the last. Sarup, you will teach in plus also. Yes, Sarup, I will start teaching in plus very soon. Very soon. Yes, it is enough. It is more than enough. And the thing is that in plus, I will teach in more details what I am teaching in now. That's the difference going to make. Okay, in very details. Okay, so see here. So see here. What are the casting defects we can have? So like what are the defects? So if I want to make something like that and I'm not getting like that, if I am desiring that I want to make this and this dimension of thing with so much of perfection, these things should be my features, that should match, but that is in actual practice that is not matching, and hence I am saying that that is a defective part, है ना? मेरे पसंद का अगर कुछ ना बने, that is a defective part, simple. So what is the casting defects we have? We have a lot of types of casting defects. First defect that I would talk to you, that is defects due to evolution of gas. defects due to evolution of gas, and these defects are also known as gas defects. Okay, now see, my dear friends, what is the defects due to evolution of gas? What is this? So see, there are a lot of defects due to this evolution of gas. First first is known as blowholes, and there are also these things are also known as blowholes and blows open blows. So what is this blowholes and open blows? Let us see with this figure. Okay, so what happens, this is my casting. So in this casting, if I have a holes in very big size, okay, very big size of holes are there like this. Okay, so these things are known as, this is known as open blows, and these are known as blow holes. Okay, so now see what is the things, that these gas defect which is formed on the surface, right? See, these are formed on the surface of the castings. So these whichever the gas defects formed on the surface of casting, that is known as open blows. Clear? So that is known as open blows, and whatever the gas defects which are in the bigger size, that is inside the casting, that is known as blow holes. Clear? So let me write it here. So gas defects which is formed on the surface of the casting are known as open blows, we have seen. Okay, and whichever the gas defects are formed inside it, that is known as blowholes, right? So we can say that gas defects which are formed inside the casting are blowholes. So I think this blowholes and open blows are clear to you. So on the surface, that is blowholes. Inside it, that is known as on the surface, that is known as open blows, and inside it, it is known as open blows. Clear? So I think these 2 points are clear to you. Now let us move to the next gas defect. What is known as, that is this next gas defect is known as scar. Okay, scar. So what is this scar? Suppose that you are having like this. So when you are doing the casting, so so after the casting has been formed, there is a very shallow, right? So this is the shallow blow formed on the surface of the casting. So shallow blow formed on surface of the casting, and this is known as scar. Clear? See, in earlier what we have seen, there is a very small amount of open part is there, but here there is a very shallow blow, right? Blow is in the shallow, okay, shallow form mein hai, and hence these are on the surface of the casting, hence it is known as scar. Next is blisters. What is this blisters? If you will analyze this scar, right, क्या होता है इसमें कि ये स्कार ही होता है उसके ऊपर, ठीक है। ब्लिस्टर्स में क्या होता है, स्कार तो होता ही है। लेट मी ड्रॉ लाइक दैट, फर्स्ट ऑफ ऑल it is having a scar, okay. So let me draw the scar, something like that. So suppose if this is my casting and this is my scar, this is my scar. Now see, on this scar is covered by, suppose there is a thin layer of metal, right? So suppose there is a thin layer of metal which is actually covering my scar, right? So these are the thin layer of metals, thin layers of metal, right? So thin layer of metals actually cover covering the scar, and these are known as blisters, ठीक है। इसको हम क्या बोलते हैं, blisters बोलते हैं, ठीक है। So we can say there is a thin layer of metal projection, okay. So you can say also the projections. So this is actually known as blister. So I hope that there is a difference between a scar and a blister, and that is clear to you, okay, that is clear to you. So till now we are discussing actually the gas defect. The first defect we have discussed, blowholes, second is a scar, third is blister, and fourth that we are going to discuss is pinhole, okay. So let me write it here, pinhole, that is known as pinhole porosity. Pinhole porosity. Now see what is the difference in this pinhole porosity. Suppose you are having the casting, right? So suppose this is my casting. Now in this entire casting, what is the difference in this pinhole? Very tiny, very tiny amount of holes are present in the entire casting, okay. So very tiny amount of holes are present in the entire casting, and these tiny holes are known as pinhole, okay, pinhole. And see what is happening actually, so we know that these are gas defects. I have already discussed that what happens when we are pouring the molten metal, and if somehow if we are allowing the air or a gaseous particles to get inside through the sprue, right, and hence we design the sprue in the taper form. This is the reason, to avoid the aspiration effect, these things we have seen. So what happens if somehow my gaseous particles or the air gets inside my casting, then gases are getting entrapped, and hence due to these things these type of defects are actually producing, because eventually since gases are trapped, but after some time these gases will try to get out from those casting, right, and when it will try to get out from those casting, hence those uh, air will leave that surface, and hence there is a vacant place in that surface, and hence see these are the vacant surfaces, right, these are the vacant surfaces leaving a big amount of holes, that is known as blowholes, leaving these kind of things, that is a scar and a blisters, and like a very small pinholes, these are known as pinholes, right. So what I can write here is that is a small size, so small size of gas holes which are formed due to hydrogen gas, okay. So these are actually produced due to the hydrogen gas, and hence these are known as pinhole porosity, pinhole porosity. So I think this is clear to you. And see what is the causes. I have already discussed causes is the hydrogen gas, clear. So what I can say here, what are the causes? Causes is the hydrogen is absorbed by molten metal inside the furnace and the cavity, right. So hydrogen gas is absorbed. See what is the thing that after absorbing the hydrogen gas, what happens once the molten metal, right, whatever the molten metal we are giving, so that is known as melt, right, molten metal is known as, that is molten metal is known as melt. So what happens after sometimes my melt gets solidified, right, so my melt gets solidified, and my melts get solidify, and it liberates dissolved dissolved hydrogen, right? So whatever the amount of hydrogen that is dissolved, hence it will get liberated, it will get liberated out, and hence very small amount of pinhole size are actually left. Okay, now see, you will ask me, sir, what are the things that we can actually use to prevent these things, right? How we can actually take the precautions to avoid those things, because these things are undesirable, right? We do not want these things. So how we can use some precautions or the preventive measures, so that these porosities or these holes like situations may not. What are the precautions that we should take it? So the precautions that you should take it is, number one, what you can do when you are melting the molten metal. See, suppose that you are taking the scrap metals, and when you are melting that metals, so while melting that metals also, my gaseous particles like hydrogen or air or whatever the gaseous particles may entrapped. Okay, so first thing that you can do it here is vacuum melting. Okay, so what you can do here is vacuum melting. Next thing that you can do it here is degassing, that is vacuum degassing. Okay, and see what happens when my molten metal is at a very high temperature, very higher temperature. Then what happens at the higher temperature, gaseous particles has a high tendency to get dissolved in that particles in that molten metal. Hence there is a thing that avoid very high pouring temperature. Okay, so avoid very high pouring temperature. So these things are that we can use here to for the preventive measures. Okay, so now if you have any doubt, then you can ask with me, is there any specific dimension to differentiate between blowholes and pinholes? Blowholes and pinholes, see, there is no such dimensions, but once you can see here, I have already told you. See, you can take a pin, okay, a very paper pin or something like that, and you will take a pin and pinch on a paper like that. So when you are pinching on a paper, it will the hole that will make like this, very small dimension, right? Very small dimension. But due to blowholes, the dimension of the holes are very big. So you can relatively distinguish that the size is very less, right? So you can distinguish by your naked eye only. Clear? Okay. So now let us move to the next part that we are actually seeing. So I hope you are understanding everything. Okay, so now see, what are the next? So first type what we have seen is this. Okay, first type we have seen is defects due to evolution of gas. Okay, so this is the defects due to evolution of gas. This is the first thing that we are seeing. Okay, so now let us move to our next part. Next part is defects due to molding material. Defects due to molding materials. Okay, now see, what is the defects due to molding materials? See what happens. Suppose that there is a cope and drag. You know that there is a cope and there is a drag. So what happens, suppose this is my casting. Clear? So this is my casting. So this is my casting, and in this casting, this is like this is your casting, right? This is your cavity. Let us assume this is your mold cavity, and throughout this mold cavity there, what is this? Suppose this section is actually molten metal, right? Suppose this entire place is filled with the molten metal. Okay, so the molten metal is there. Okay, so this entire place is filled with the molten metal, and this is the cavity, right? Now see here what happens actually. I'm telling you, first to try to understand these things. So what happens that molten metal will try to reach here, right? Molten metal will try to reach here, but once it will reach here, what happens? Due to the adjustment of cope and drag, है ना? Due to the there is a cope and there is a drag, right? So what happens when you are not doing the uniform ramming? Let me clear. When you are not doing the uniform ramming, improper ramming is there, then what happens? The sand particles are very loose, right? They are not binded with that force. So what happens that a small amount of a very small amount of sand particles, suppose from a cope box, get here. Okay, so due to the improper ramming, the molding sand in this in from the cope box, like dropped from the cope box to the drag box, like, so it get here. So very small amount of molding sand get here, and what happens? Suppose that like this, suppose like this. So what happens when the molten metal gets here, right? Suppose my molten metal is filling this part. Suppose the molten metal is filling this part. So what happens? My eventually my casting. Okay, so there was some issues at my end. Okay, so see here, what are the defects that I was actually teaching to you? Okay, so हम यहाँ पर थे. Is my audio video clear to you now, or still you're facing the problems? Just let me know. Okay, okay. So now what I was telling to you, that defects due to the molding material. So what happens? What are the defects that we are actually seeing due to this molding materials is this. So I have told you that due to improper ramming, if the molding sand will be dropped from the cope box to the drag box and will form a projection on the surface of the casting. See, there is a projection on the surface of the casting, that is known as drop. Clear? That is known as drop. And suppose that if this is, if these things like that, if you are getting some projections on the bottom side. So if you are getting any projection, suppose that if you are getting any projection on the top side, that is known as drop, and on the bottom side, that is known as dirt. That is known as dirt. Clear? So these things are due to the improper ramming. Okay, so due to the improper ramming. Why? Because due to the improper ramming only, my sand particles are not bounded very cohesively, and hence these small part of molding sands, or these will drop on the casting, and hence form a drop. Since molding sand is dropped, and hence the casting is known as, hence the defect is known as drop. Clear? Now see, next is something which is called as, this was actually named as drop and dirt. Next defect, that is known as cuts and washes. Okay, so cuts and washes. So what is this cuts and washes? Suppose that I have a casting like this. Okay, and this is my gate. So what happens that due to the improper ramming, so again I'm telling that these all the defects due to the molding material is only and only due to the improper ramming. So keep in mind that defects due to the molding materials is due to the improper ramming. Improper ramming. Okay, so what happens due to improper ramming? What happens? These casting, the mold, that is the sand particles, comes here, right? So cut it down and leave these sand particles like here. Suppose that these everything everywhere this is sand. Suppose that every place that is there is a presence of sand. Now what happens? These sand particles cut away from here like that. So it is cut from here and it is washed here. And hence it is washed here and making a projections like this. Okay, making a projections like this, and hence this type of defect is known as cut and wash. Okay, so due to the improper ramming, so what are the reasons? Due to the improper ramming, okay, and improper gating design. So if these things are there, the molding sand will be eroded. So here from here molding sand eroded and hence washed into the cavity, right? So what we can say here, molding sand eroded and washed into cavity. Okay, see here, it is washed into this cavity. You can see here, very easily you can see here, and hence this projection. So this projection is actually known as cut and wash. This projection is known as cut and washes. So I think these things are clear to you. Okay, I hope these things are getting clear to you. Now see, next defect that is known as scab. Okay, so let me write it here. The name of the next defect that is known as scab. Okay, that is scab. So what is this scab? What happens that suppose that due to the improper ramming, suppose if liquid metal can be penetrated in the loose sand layers, what I can say here, suppose like this. Suppose there is a uh, so this is my cavity. Suppose this is my cavity. Okay, and these whole things are my sand particles are there here. So now what happens when you are pouring the molten metal here? Suppose this the from here, like you are pouring the molten metal, right? So you are pouring the molten metal here. So what happens when you are pouring the molten metal? What actually does this liquid metal penetrate on the loose sand? Okay, suppose that liquid metal penetrated in this sand particles like this, and hence it will form these kind of structure. Okay, so see in this drop, what was happening? Molding sand actually dropped from the cope. Molding sand dropped on the drag box. From the cope box to drag box, molding sand dropped here, and due to this dropping of here there is a projection, and hence it is known as drop. But here what happens that my liquid metal actually penetrate in this loose sand layer, right? And hence these kind of projections get to us. So let me write it here that due to, again I should write it because after that you will forget everything. So due to improper, again I have told you that every cases would be here would be due to the improper ramming, right? So due to the improper ramming, if the liquid metal if the liquid metal can be penetrated into the loose sand layers. See why there is a loose sand layers, because there is improper ramming, right? And hence these metal get penetrated like this. Okay, like this, like this, like this. So what you can say here, due to the improper ramming, if the liquid metal can be penetrated into the loose sand layers, and hence will form a projection. So this is a projection, and this projection is actually known as scab. Okay, so that is known as scab. Clear? So I think this concept of a scab, drop, dirt, there is a difference between drop and a scab. It may look like the same, but this is not the same things. These are happening due to the different phenomena. Okay, so I hope these defects due to the molding sand. So now we have seen the defects due to the molding material. Clear? So always keep in mind that due to this molding material, whatever the defects you are facing, that is due to the improper ramming. So how to avoid these things? Do proper ramming. Very simple. So whatever the defects due to the improper ramming is happening, so follow the procedure, follow the standards used by the foundry personnel, and hence follow the proper ramming methodologies, and hence this is the precautions. Okay, so I hope these things are clear to you. Now see, we have seen these things: defects due to evolution of gas, defects due to molding material. Now the next defect that we are going to see here is defects due to shrinkage. Okay, defects due to shrinkage. Now see what is happening in this defect due to shrinkage. Due to improper riser design, this defects actually happens. Now suppose that if you want to make, suppose that there is a riser like that. Okay, suppose this is my riser, and this is the casting that you actually want to make. So okay, so there is a riser in which molten metal is filled, right? Now what happens actually, see here, what happens that molten metal is here, right? So molten metal is poured and molten metal is here like that. Now due to the improper riser design, what happens that I have designed the riser such that it should compensate the liquid sinkage, right? It should compensate the liquid sinkage. But what happens due to this improper riser design, cavities are formed due to shrinkage, because there is a like a solidification problem is there, or any kind of problem is there. So this cavity which is formed here, right, that is known as defects due to shrinkage. बिकॉज सी, श्रिंकेज जब होता है हमारा, तो राइजर का काम क्या है कि श्रिंकेज जहां भी हो रहा हो उसको कंपनसेट करे, मोल्टेन मेटल को सप्लाई करे वहां पे। लेकिन अगर मेरा राइजर जो है, राइजर में कुछ त्रुटियां होंगी, राइजर में कुछ प्रॉब्लम्स होंगी, तो क्या होगा, आपने इम्प्रॉपर कैलकुलेशंस की, आपने राइजर को ठीक से डिजाइन नहीं किया, तो किस तरह का प्रॉब्लम हमें फेस करना पड़ेगा? हमें प्रॉब्लम ये फेस करना पड़ेगा कि राइजर जो है वो पूरी तरह से यहाँ पे मोल्टेन मेटल दे नहीं पाएगा, और जब पूरी तरह से मोल्टेन मेटल दे नहीं पाएगा तो श्रिंकेज के कारण जो कैविटी बन रही है उसको फिर कंपनसेट कैसे करेगा? एंड हेंस यू आर गेटिंग दीज काइंड ऑफ थिंग हियर, एंड दिस इज नोन एज ड्यू टू श्रिंकेज. सो लेट मी राइट इट हियर: ड्यू टू improper riser design, cavities formed due to shrinkage of the material is known as is known as shrinkage cavity. Okay, so I think this concept is clear to you. What is the shrinkage cavity? Okay, so this is my riser, this is my riser, so don't worry about it. And this is these things are like liquid metal is there, but liquid metal is inappropriate to fill this cavity. Okay, and this is my cavity is formed here, the cavity is formed. So I think defects due to shrinkage is clear to you. Okay, now let us come and see the next defect that we are going to see here. What is the next defect is here? Next defect is defects due to defects due to pouring of melt. What is this melt? I have already told you, molten metals. Okay, so this is known as melt. So now these defects are due to what I can say here. In these defects, how you can identify that there is a defect due to the pouring of melt? Only and only you have to see here, there will be in these kind of defect, there will be a unfilled cavities. Okay, so let us see what are the defects in these things. So first type of defect here is first type of defect is misrun. Okay, misrun. And second type of defect is cold shuts. Okay, second type of defects is cold shuts. In this defect due to pouring of melt, what happens that suppose that you have a cavity like this. Okay? So a cavity like this, and see what happens. You are pouring the molten metal from here, the molten metal is poured. So what happens, the molten metal is poured here, but somehow due to any reasons, any of the reasons could be there. So to somehow what happens, this molten metal actually solidify, actually this molten metal solidify here. Okay, so my molten metal solidify here, and hence leaving a unfilled cavities. Okay, so why this is there, why this problem arises? This problem arises due to the insufficient fluidity of the molten metal. So my molten metal having very less fluidity, it cannot flow, and before reaching the cavity, right? So see, this is the key, this is the cavity. Before reaching the cavity, liquid metal gets solidified. Okay, so here liquid metal gets solidify here, liquid metal solidifies before reaching the cavity, so this kind of defect is known as misrun, right? So I should write here insufficient due to the insufficient fluidity and pouring temperature, है ना? यहाँ पर आते हैं, अगर मेरा मोल्टन मेटल का टेम्परेचर बहुत कम हो जाए, ठंडा हो जाए, बहुत कम टेम्परेचर हो जाए, तो वो ऑलरेडी सॉलिडिफाई कर जाएगा ना. सो दिस इज द रीजन ऑल्सो. सो pouring temperature. So due to the insufficient fluidity and pouring temperature, my liquid metal is getting solidify before reaching the cavity. Clear? So that is actually known as my then this kind of defect is known as misrun. Clear? So I think this misrun is clear to you. Next defect that is actually cold shut. Now see, what is this cold shut? Suppose that you have this kind of cavity. Clear? Suppose that you have this kind of cavity like this. Okay, Now suppose that what you are doing, this is the one gate and this is the another gate. So suppose that you are using more than one gate, that is two gates, right? So here is one gate and here is another gate. So you are using the two gates to pour the molten metal into this cavity, right? So suppose this is my cavity, and in this cavity you are pouring the molten metal. So what happens actually? So what happens actually? So you are pouring the molten metal. So you are pouring the molten metal. So molten metal will be poured like this. Okay, so molten metal will be poured like this. But what happens as soon as they will reach at some point? Suppose at this point molten metal has been poured and they are reaching at this point. Suppose the molten metal you are pouring from here, okay, and from here also it has reached to some points. Now what happened after reaching at some point? There is a problem. There is a problem in a fusion. व्हाट इज हैपनिंग, जब एक गेट से आप किसी मोल्टन मेटल को दे रहे हैं, दूसरे गेट से किसी और मोल्टन मेटल को दे रहे हैं, तो व्हाट इज द प्रॉब्लम इज दैट these are the two stream, right? So this is the one stream and this is the another stream. So what is happening, two streams of liquid metal at this point they actually not fuse properly, right? So what happens here, they are not fusing here, they are not fusing here, and hence they are forming a layer like that. Due to this they are not fusing properly, they are not fusing properly, and hence a layer, that is unfused layer, is actually formed in between it. It is an unfused layer that is formed in between it, and that is actually known as cold shut. Okay, so that is known as cold shut. So what happens actually, what happens actually, what you can say here like this, up to this molten metal is there, up to this again the molten metal is there, and due to this they are not fused properly. So there is a unfilled, there is an unfilled cavity here. There is again, there is an unfilled cavity here, and this unfilled cavity is actually known as cold shut. Why this cold shut is there? Because two streams of liquid metal will not fuse properly and will form a discontinuity. Clear? A discontinuity in the casting, and this led to an unfilled cavity, and this is known as cold shut. So I think defects due to the pouring of melt is clear to you. So till now we have discussed, so till now we have discussed three types defects due to the pouring of melt. Okay, so pouring of melt. So till now we have seen defects due to shrinkage, defects due to shrinkage. Okay, defects due to shrinkage, defects due to molding material, defects due to evolution of gas. So four types of defects, four categorized type of defects we have seen till now. Now what happens, there is another category of defects, that is actually, there is another category of defects, that is actually that is four, right? So we have discussed four, so let me write it here, five. So this type of defect is known as defects due to metallurgical factors. Defects due to metallurgical factor. Now what is this metallurgical factor? What is this defect due to metallurgical factor? See, there are some defects, there are some defects that actually due to, that happens actually due to non-uniform cooling. Okay, non-uniform cooling is there, right? Non-uniform shrinkage, stress formed, stresses developed. Okay, so what happens that suppose what happens कि आप suppose करें कि आपको ये पता है कि आपका जो डाई होता है ना, इफ इट इज अ डाई और अ मोल्ड कैविटी, दैट इज एक्चुअली एट अ लोअर टेम्परेचर, क्लियर? सो माय मोल्ड कैविटी or any die, we have discussed yesterday what is the meaning of a die, that is the metallic thing, right? So we have seen that either in case of a die or in case of a molding cavity, whatever is there, that are at a very lower temperature, है ना, बहुत कम टेम्परेचर होता है. Now they are at a very less temperature, lower temperature, and all of a sudden what you are doing, you are pouring a very high temperature molten metal, clear? So what happens, that cavity is at a low temperature, you are pouring a molten metal at very high temperature. So what happens actually, there is a generation of non-uniform shrinkage stresses. Okay, so there is a generation of non-uniform shrinkage effect. Okay, Naman, I will discuss these things at last stage. Okay, आप जो भी हैं, शुभम को भी मैं बोल दे रहा हूँ, शुभम जी एंड नमन जी, रिमाइंड कर दे मुझे लास्ट में, जब मैं सेशन के लास्ट में मैं डाउट्स लेता हूँ, आप उस समय रिमाइंड कर दे, मैं आपका सारा डाउट्स क्लियर करने की कोशिश करूंगा. ठीक है, चलिए. नाउ सी, defects due to metallurgical factors. So we have seen that there is a non-uniform or a shrinkage stresses developed, है ना, क्योंकि मोल्ड जो होता है हमारा वो ठंडा होता है, या डाई जो होता है वो हमारा ठंडा होता है. अचानक से आप उसमें गर्म, very high temperature of molten liquid you are actually pouring, and due to this there is a sudden or abrupt or a non-uniform shrinkage stress developed. What happens also, there is a non-uniform cooling, and due to these things what happens, that suppose that you are getting a casting like this. So what happens actually, when you are making a eye section, suppose you are making a eye section, and when you are making a eye section you are getting a tears, right, a tears like this, and this is actually known as a cracks like this, right? So there is a cracks, there is a cracks like this, and let me tell you, there is a name of these kind of cracks, that is known as hot tear. Okay, so these kind of hot tears are there that actually formed on the surface, that is on the edges, mostly that are actually on the edges. And what are the reasons they are forming? They are forming due to the non-uniform cooling and non-uniform shrinkage stresses, development of non-uniform shrinkage stresses. So these kind of tearing out of the part, that is known as hot tear. Clear? So I think that is clear to you. So this is the defect due to metallurgical factors, right? Now see, so I have already told you that due to non-uniform cooling, non-uniform shrinkage stress can be developed in the casting, and if the stress will be more, right, see, if the stress that is formed will be more the strength of this, right, the strength of this material, obviously there would be a crack, right? So obviously there would be a crack, क्योंकि इसका मटेरियल का स्ट्रेंथ से ज्यादा मेरा स्ट्रेसेस है, श्रिंकेज स्ट्रेसेस का वैल्यू ज्यादा हो गया, so there would be a crack. Now what are the precautions that you can take it here? What are the precautions? So precautions that you can take it here, so what are the precautions that you can take it here? You can actually use chills and padding. I have already discussed these things, what are chills and padding. So when you will use the chills and padding, what is the benefit of using chills and padding? Can you tell me? Give me a reply that what is the benefit of using chills and padding? Please tell me what is the benefit of using chills and padding. Please tell me why we are using chills and padding, or you have forgotten everything. Okay, so let me tell you, yes sir, control the cooling. See, what are the use of these chills and paddings? That they are actually providing the uniform cooling, right? So uniform cooling is there, direction solidification, these things are there with the chills and padding. So there is a uniform cooling, and hence these precautions are actually help you to get out from the hot tears. Okay, so I think this is clear to you. Hot tears is clear to you. Proper cooling rate at intricate sections. Yes, yes, yes. Subham, Raj and Ashish, yes, very good answers, good answers. ठीक है, तो ये सब जो चीज है, डिफेक्ट्स ड्यू टू द मेटलर्जिकल फैक्टर, एंड हेंस दैट these are the these defects is my fifth kind of defect due to metallurgical factors. Okay. Now next kind of defect is, let me talk the next kind of defect, that is due to, the name is due to defects due to other factors. What is defects due to other factors? So first defect that you have to study here is mold shift. Okay, mold shift. Now see what happens. What happens, you have actually firstly you have placed a pattern, and then you have put the small green sand over there, you did the uniform ramming, after that you placed in the drag, so cope and drag arrangement is, everything is fixed. Now see what happens, there is a problem in the mold shift, is that due to improper positioning of cope box on the drag box, right? So what happens, suppose that you are uh, positioning the cope box like this, there is a cavity, there is a cavity like that, and in place of that you have actually positioned the drag box like this. Okay, and due to this what happens, that my mold is like this. Clear? So I'm getting a cavity like this. So I'm getting a cavity like that. So this is my cope and this is my drag, right? So when I will do the casting, when the molten metal will be poured here, so then I will be getting something like that. Okay, so I will be getting a casting something like that. Okay, so something like that I will get the casting. So see, this is actually known as mold shift. My mold actually shifted. Clear? So my mold actually shifted. Now see, what are the what, how you can prevent it, how you can prevent these kind of mold shift? So by using the dowel pins. See what you can do here, that suppose that, okay, so suppose that this is the cavity, this is the cavity. Okay, so this is the cavity. Now you will use the clamps. Okay, so you will use the clamps to fix this arrangement, and with, there is a dowel pin. This pin is known as dowel pin. Okay, so you will use the dowel pin to clamp this thing. So what is this dowel pin? Dowel pins looks like this. Okay, I have explained the dowel pins in the earlier sections also, but still I'm telling, this is the dowel pins, right? So this is the pin, and this is actually getting in this kind of fixture. There is an internal hole here. So this dowel pin is actually here, and with this help of clamping, proper clamping, you can actually remove the problem of molding shift, right? So by providing the dowel pin, by providing dowel pins and clamps, you can actually avoid this mold shift, right? So again I am telling what is the causes of this mold shift. So causes are actually improper positioning of cope box on the drag. Okay, and hence there is a mismatch. Okay, and hence there is a mismatch along the parting line. Okay, so there is a mismatch along the parting line. So this is my parting line. This is my parting line. So there is a mismatch in this parting line, right? So this is known as mold shift. Okay, so I think this mold shift is clear to you. Okay, so I'm not getting any doubt. So I think this mold shift is clear to you. So this is the defect due to other factor, and the first defect is mold shift. Clear? The first factor is mold shift. What is the next defect? What is the next defect? Next is core shift. Core shift. What is this core shift? Let us understand this core shift with the help of figure. Suppose that this is the mold cavity. Clear? And in this mold cavity you are using a core. Suppose this is the core. Clear? This is the core. This is the core and this is the mold cavity. Okay, so see, eventually if you will project these things here, right? Let me project it here. So when you will project it here, you will get a casting like this. Okay, there is a hole here. Clear? So this hole is actually when you will draw the axis. Okay, so when you will draw it, you are actually getting this kind of thing. But what happens, let me draw the another figures. What happens when you have poured the molten metal? Okay, so when you have poured the molten metal, what happens that there is a actually buoyancy, right? So actually due to the buoyant force, what happens, this core is actually this core actually moves upward. Okay, so this core actually moves upward due to the presence of the buoyancy force. Okay, so what I can write here, shifting of the core from its original position due to upward buoyancy. Okay, so due to upward buoyancy. So what happens, my core is now shifted out. Now see, if you will project here, suppose if I am projecting the, let me project here. Now suppose if you will project it here and analyze what happened due to this core shifting. Okay, so what happens this due to the core shifting is like this. So you are interested to to get the product like this that I have drawn here. So this is the desired casting. Okay, so this is my desired casting, and due to this desired casting, what I am getting a hole here, right? So I am getting a hole here, and see, due to this, if I will draw my axis line. Okay, so you can see here, earlier I was having the axis like this. Okay, earlier I was having the axis like this, but now my hole shifted out with some distance. Suppose this is distance is E. Okay, and see, due to the shifting of core, I am getting a variation in my product, right? So this is not the desired, so this is not the desired casting, right? So hence there is a defect, and hence there is a defect, and this defect is known as core shifting of core. Hence this defect is there. Now how you can actually remove these kind of defects, or how what should you your uh, strategy should be there to overcome these defects, right? So the precautions that you should take here, so better to say what are the remedies, right? So what are the, sorry, better to say remedies. Okay, better to say remedies. So what are the remedies that you can actually follow here? That There's remedies that you can follow here by providing prints, right? Core prints, right? So we are providing the core prints. core prints क्यों प्रोवाइड करते हैं? core prints अगर हम प्रोवाइड करते हैं तो मेरा core क्या होता है, एक जगह पे फिक्स होता है ना? तो मुझे पता है कि अगर मैं core के को core prints लगा दूं, यहाँ पे सपोज करूं मैं यहाँ पे core prints को लगा दिया, ठीक है, कोर प्रिंट्स को लगा दिया। कोर प्रिंट्स को लगाने के साथ साथ मैंने इन जगह पर चैपलेट्स लगा दिया। सपोज करें कि मैंने इस जगह पे चैपलेट्स लगा दिया, ठीक है। अगर मैं कोर प्रिंट्स लगा दूं, चैपलेट्स लगा दूं इस तरह से, तो क्या मेरा कोर मूव करेगा? क्या कोर मूव नहीं करेगा। और अगर कोर नहीं मूव करेगा तो इस तरह का बॉयंट फोर्स उस कोर को मूव नहीं करके जा सकता है, एंड हेंस द कोर शिफ्ट विल नॉट बी देयर, राइट? सो hence what we can use here, by providing the core prints and chaplets, we can actually nullify the chances of core shift. तो सर ये सारा डिफेक्ट समझ में आ रहा है? आर यू अंडरस्टैंडिंग दिस ऑल डिफेक्ट्स और नॉट? यूं तो कहने के लिए काफी सारे डिफेक्ट्स है, स्लैग इंक्लूजन्स भी होता है ना? अगर कोई एक्स्ट्रा फॉरेन पार्टिकल्स आके वहां पे चिपक जाएं, कास्टिंग में हमारा मिल जाए, दैट इज नोन एज स्लैग इंक्लूजन्स, है ना? तो कहने के लिए बहुत सारे डिफेक्ट्स होते हैं, बट ब्रॉडली दीज आर द डिफेक्ट्स दैट आई हैव टोल्ड यू, एंड if you have any doubt in the defects that I have taught you right now, you can ask me the questions regarding the defects. Okay, you can ask me the questions. So I have discussed casting defects like defects due to evolution of gas, and in this I have discussed blowholes, open blowholes, scar, blisters, pinhole porosities, and defects due to molding material I have discussed. So whatever the defects due to the molding material would be there, that is due to the improper ramming. So first defect that is you can see here is this, that is drop and dirt. Okay, so drop and dirt, cut and wash, cut and wash. Scab is there, right? So scab is there. Defect due to shrinkage we have seen. What are the defects due to shrinkage can happens? Next defect due to the pouring of melt we have seen. The first is the misrun. Okay, so we have seen the misrun is there. There is a cold shuts. Okay, and defect due to the metallurgical factors we have seen. सर मैथ्स पढ़ाइए। मैथ्स मैंने बहुत सारा किया है, and after defects I will give you a lot of numericals. Okay, we are going to solve a lot of numericals. Don't worry Rahul ji, don't worry. So these are the things that we have seen till now. So if you have any doubt till now, ask me, so that if you don't have any doubt, then let me know so that I can proceed it. Okay, I'm waiting for some time, and after waiting for like I'm giving you 10 seconds time. If you are giving me any reply that if you have any doubt, then okay, else I will move to the next part. Okay. दिनेश जी मैंने अपना इंट्रोडक्शन दे दिया है, ठीक है, काइंडली चेक दैट। और अभी जो है ना, खास करके कोर्स कंटेंट को लेकर के क्वेश्चंस पूछे, दैट विल बी हेल्पफुल, है ना। You can check my introductions and you can follow me at the Unacademy app at the rate of v.kser. So see, so I assume that your all doubts are clear now. So let us solve some good amount of questions like this. Okay, so let us solve these questions. So I'm giving you some time to solve these questions, like approx some minutes. Give a try and tell me the answers. Tell me the answer. I'm waiting for your reply. See, in this question, a cylindrical riser of 6 centimeter diameter. Okay, so there is a riser of 6 centimeter diameter. So can I write like that, that there is a height of riser? Let us assume this height to be h. This is given as 6 centimeter. Next what? And cylindrical riser of 6 centimeter height and 6 centimeter diameter. So let this diameter will also be diameter of riser. Let's this diameter of riser to be 6 centimeter. So I think it is not clear to you. So this is D. This is actually 6 centimeter. Next is what is to be designed for a sand casting mold for producing a steel rectangular plate of 7 centimeter, 10 centimeter and 2 centimeter dimensions. So what are these dimensions? These dimensions are given of the casting. So can I say that volume of casting, that is given as 7 cross 10 cross 2. So 7 cross 10 cross 2. Okay, so 7 cross. This is the thing that is given. Now see, having the total solidification time of 1.36 minute. Okay, so this is given as 1.36 minutes. That is what? Total solidification time of casting is given as 1.36 minute. Clear? See, casting mold for producing of this have a 1.36 solidification time. Now what is being asked? The total solidification time of the riser. So in this question, total solidification time of riser has been asked. How you can find the total solidification time? Very simple. First of all, you have to use this relation, that is total solidification time is actually proportional to V by A whole square. Use this relation and find the answer. Tell me the answer. Use this relation and find the answer. Okay, so I have explained the question. Try to solve this question and give me the answer. Okay. Tell me the answer. It's a very simple question. Just apply the formula and you will get the answer. Okay. Any answer? Okay, so I am solving the question. Okay, so I have waited for your reply. See here, in the cylindrical riser, this is 6 centimeter diameter, 6 centimeter height. These things are given to you. Volume of casting is given to you. Total solidification time of the casting is given to you. You are required to find the total solidification time of the riser. Now see how you can find. You have to calculate the volume and you have to calculate the surface area, right? So these things that you have to calculate it. Now see, let us first try to find the, we know that the volume, so what is the volume of the metal of the casting? So volume of casting is 7 into 10 into 2. See here, 7 into 10 into 2. So what is this? This is 140 centimeter cube. Now see, what would be my surface area of the casting? That would be twice of 7 into 10 plus 10 into 2 plus 2 into 7. Clear? Now if you will calculate it, you will get as a, so you will get around 208 centimeter square. Clear? So you will get 200 square. So volume of casting, area of casting is known to us. Now what is the thing? See here, the riser, height of the riser is given and diameter of riser is given. So both are what? Same. H is equal to D. Both are given. So now I know that what would be my volume of riser? Volume of riser. So what is the volume of riser? Let this volume of riser to be VR, right? So what is this? This would be pi by 4 D square into H. Now see, we have seen that since H is equal to D, that is both are is equal to 6. So can I say that pi by 4, 6 square into 6, right? So this is my thing. So this would be, so this would be 54 pi, let pi. Okay, so this would be my volume of riser. Clear? This would be my volume of riser. Now if I will calculate area of riser, that would be AR, surface area of riser. Let it to be AR, and this to be VR. So what would be the area? That would be pi dh plus pi by 4 d square. Clear? Pi by 4 d square. Now see, if I will calculate it from here, then I will be getting something like that. Pi into 6 into 6 plus pi by 4 into 6 square. Okay. So I will be getting, so this would be my 36 pi. Clear? So this would be my 36 pi and this would be my 9 pi. Clear? So that would be total, in total that would be 45 pi. Okay, that is 45 pi. So what we can see here, that I got VR, I got AR, VC, AC. So just I have to put in the equation, that is total solidification time of riser. See, we have seen that it is proportional to V by A, right? So it is proportional to V by A. So if I will write total solidification time of riser by total solidification time of casting, that would be is equal to volume of riser by area of riser whole square into area of casting by volume of casting whole square. This is the thing. Now if you will put out the figures, VR, what is VR? 54 pi by 45 pi whole square into 208 by 140. Okay, so what is this 208 and 140? See here, you have got the area to be 208 and the volume to be 140. So once you will calculate it, you, this pi get cancelled out. So you will be getting something like that. Let me calculate it. And see here, this TST of R, I can write like that, TST of R by TST of casting. I know that total solidification time of casting is 1.36 minute. I will put it here 1.36 minute, and this is equal to this 54 pi by 45 pi whole square into 208 by 140, right? And from here you have to calculate total solidification time of riser. So let me calculate it here. Okay, so you are getting total solidification time of riser to be 4.32 minute. Any doubt? Yes, assess, right. Any doubt? Do you have any kind of doubt? Okay, so now I think this is clear to you. So if this is clear to you, try to solve this question. Try to solve this question. Okay, try to solve this question. Try to solve this question. I am giving you some time. So in this question, what is given, I'm just discussing the question. The solidification time of a casting is proportional to V by A of whole square, right? So the rule is given where V is the volume of casting, A is the total casting surface area losing heat. Clear, these things we know. Two cubes of same material. Okay, so there is a two cubes of same material and size are cast using the sand casting process. Okay, fine, no problem. The top face of one of the cube is completely insulated. So suppose this is my cube. Okay, this is my cube. So this cube, what is being told here, that the top face, okay, so suppose that my top face is this is my top face, right? So this is my top face. This top face is actually insulated. Yeah, so let this to be insulated. Okay, so my top face is insulated like this. So my top face is insulated. These things we know. Okay, top face of one of the cube is completely insulated. So I have completely insulated. Suppose I have completely insulated. So this is my insulation. Okay, so there is an insulation. Now they are asking that the ratio of solidification time for the cube with top face insulated to the other cube, okay, so let me assume that, so this is my other cube like this. Okay, so let us assume this cube to be 1 and this cube to be 2. Okay, and based upon that you have to calculate the simple ratio of solidification time ratio you have to calculate, and see what is the answer. Just tell me the answer. B. Okay, very fast, very fast. Okay, very good, Indrajit. Answer is B. Answer is B. Yes, answer is B. और लोग क्या कर रहे हैं? I have explained the questions. If you have any problem, I don't know what to say to you. A, 25 by 36. No, no, that is B. See, in this question, it has been asked ratio of solidification for the top face insulated to that of the other cube, right? So from here, you are required to find T2 by T1. Okay, so I think you have found T1 by T2. No, T1 by T2 is not correct. Okay, see here, see the things, and then we are going to see here. Now see, what would be the volume of these cube? Okay, so let me write here. So volume would be like what? V1. So this is the volume V1 of first cube, that is V, and here also V1, V2 is equal to V. Both are the both volumes are same. So I can say that both volumes are same, and since both volumes are same, then I can say that A1 is equal to A2 is equal to A. Clear? Now if I will find the surface area of this two, then that will be what? Surface area will be 5a square. Why 5a square? Because one surface is insulated, and here when I will calculate the surface area, here when I will calculate the surface area, then this would be 6a square. Clear? Because this one, all the surfaces are open, and here one surface is insulated, and hence there is a 5a square. Now see, I have calculated a2, I have calculated a1, v1, v2 is everything is known to me. So now what I can they say here, since one surface is insulated, since one surface is insulated. Okay, so having known these things, what we can write here, the total solidification time for 2 is by total solidification time for 1 is nothing but V2 by A2 whole square by A1 by V1 whole square, right? Now see, V2 and V1, V2 and V1, see, V2 and V1 both are same. Okay, so what is this? This is A cube. What is A2? See here, what is A2? A2 is 5a square, right? So I can write here that is 5a square, and see this A1 will be what? 6a square. This would be A cube. Okay, A cube. If you will calculate it, you will get A cube. If you can get cancelled, you are getting 6. This is whole square, right? So 6 square by 5 square. So you are getting as T2 by T1 is equal to 36 by 25. Okay, 36 by 25. So any doubt? Any doubt in this question? Very easy question is there, but yes, you have to think very properly. Whatever the concepts you have learned throughout the casting, you have to apply those concepts. Okay. Now see, let us say this question. Try to solve this question. Try to solve this question. Try to solve this questions. Answers has been given by Indrajit, Ashish, Shiv Kumar. Correct answers. Correct sir. Correct. सभी लोगों का करेक्ट आंसर है. Try to solve this question. Okay. Let me explain this question once again. There is a cube and a sphere made of cast iron. Clear? So cube and a sphere made of cast iron, and both have the same volume, that is 1000 centimeter cube. Clear? Were cast under the identical conditions. The time taken for solidifying the cube. Okay. So time taken by this cube to solidify is 4 seconds. That is total solidification time for cube is given, and solidification time for that of a sphere has been asked. So again the same question, same type of question is there, but a little bit things are different. Try to calculate the question. Try to calculate and find the answers. इन दिस सेशन जो है मैंने काफ़ी कुछ इनकॉर्पोरेट करने का कोशिश किया है, ऑलमोस्ट एवरी टाइप ऑफ क्वेश्चंस, सो दैट आप जब क्वेश्चंस बनाएं तो आपको कोई प्रॉब्लम ना हो, और कास्टिंग खत्म होने के बाद आप प्रीवियस ईयर खोल के बनाएं, सॉल्व करें, प्रैक्टिस क्वेश्चंस लें, बनाएं उसको, यू विल बी एबल टू सॉल्व दोज थिंग्स. Tell me the answer. Okay. See here. See here. A cube and a sphere made of a cast iron, each of volume 1000 centimeter cube. Okay. So let me write it here. There is a cube. There is a sphere. Okay. So there is a cube, right? So cube has a volume of 1000 centimeter cube. Volume sphere has a volume of 1000 centimeter cube. So both has the volume to be same, right? Now see, I can say there is a cube. So can I say that v1 is equal to a cube, which is nothing but is equal to 1000. So from here I can say that my a will be 10. Okay, so my a will be 10 centimeter. Yes, Ashish, your answer is correct. Your answer is correct. So I will be getting a is equal to 10. Clear. Now if I will calculate a1 surface area, what will be it? It will be 6a square. So what would be 6a square? 6 into 10 square, that is 600 centimeter square. Clear. Now let us analyze the situation of a sphere. So v1 is equal to 1000. So that is what? That is 4 by 3 pi r cube is equal to 1000. Right. From here you will calculate the value of r, and the value of r that you are getting at 6.203 centimeter. So from here you are getting the value of r to be 6.203 centimeter. Now you want to calculate the a2, that is the surface area. So how you will calculate surface area? 4 pi r square. What is 4 pi given? R is given as 6.203. So squaring these things you are getting a2. So you are getting a2. A2 is what? 483.52 centimeter square. So you are getting this a2. You know this v1. You know this a1. You know this v1 and v2. Both are the same things. Now you know these things. Now you can apply the total solidification time is actually proportional to v by a whole square. Clear. So let me write as t1 by t2 is equal to v1 by a1 whole square into a2 by v2 whole square. Clear. Now see, what is v1 and what is v1 and v2? Both are same, right? And see, a1 is 600 and a2 is 483. So I will write as v1 and v2 are same. So what is this? This is 1000. A1 is coming to be 600, isn't it? Yes, a1 is 600 and a2 is 483.52. So this is actually 483.52 by 1000, right? And these are square. Clear. So these are squares. Now see here, you know that the time taken by solidifying the cube, that is 4 seconds, right? So this is my 1, this is my 2. So can I say that t1 is given as 4 seconds? So putting here that 4 seconds by t2 is actually is equal to this 1000. This 1000 will be cancelled out. So actually you are getting as a 483.52 by 600 whole square, and if you will calculate from here you will be getting as 6.16 seconds. Any doubt? हम्म समझ में आ रहा है? समझ में आ रहा है? जिनसे नहीं बना था ये क्वेश्चंस, is this concept clear to you? How to approach the questions? How to approach the questions? The answer is going to be my 6 point. Second it has been asked. So I hope this question is clear to you. Now try to solve this question. Now try to solve this question. Okay. See here. In this question, the ratio of solidification time of a cylindrical casting, that is given as height is equal to radius. right? So height is given as is equal to radius to that of the cubic casting of side 2 times the height, right? See, first in first case what is given, that height is equal to radius, so height is equal to radius. Clear? So height is equal to radius is given for a cylindrical, casting. See, cylindrical casting. Now see, next thing that has been given, that for a cubic casting, side 2 times the height of cylindrical casting. So for a cubic casting, what is given, that my a, that is suppose the side is a, so a is equal to what, 2h. A is equal to what, 2h. Now based upon that, you have to calculate the ratio of solidification time of a cylindrical casting to that of a cubic casting. So again same thing is there. What you have to do it here, see here, volume of cylinder. How you can calculate the volume of cylinder? Pi r square h, right? Now see here, you know that h is equal to r, so you can write here pi h cube. Why? Since r is equal to h. Clear? You will calculate the area of cylinder. Suppose you are calculating the area of cylinder. How you will calculate it? 2 pi r square plus 2 pi r h, right? Now see, you know that r is equal to h. You can write here that 2 pi h square plus 2 pi h square. So all in all you are getting as 4 pi h square. So you are getting area as 4 pi h square, you are getting volume as pi h cube. Clear? So you are done with this, you are done with the cylindrical cylindrical things. Okay, now let us see about the cubic. Now see, for a cubic casting, what is the volume of cube? That is equal to a cube. Now see, I have given that a is equal to 2h, right? So can I say that 2h of whole cube is this, that is 8h cube. Why? Since a is equal to 2h, which is given. Clear? So I know volume of cube. Now I can find the area of cube. What is this area of cube? See, area of cube would be 6a square. Clear? 6a square. Now what is a? A is 2h. So can I say that 6 2h whole square? So that is going to be is equal to 24h square. Clear? So what are the things that is known to us? I know volume of cube, that is pi h cube. I know area of area of cylinder and volume of cylinder, that is actually area of cylinder is 4 pi h square. Volume of cube, that is 8h cube. Area of cube, that is 24h square. Clear? So I am knowing these values. Now see what I know that total solidification time for case of a cylinder. Suppose you are finding the total solidification time for case of a cylinder. What is this? Is this proportional to volume of cylinder by area of cylinder whole square? Clear? So I can see here that this is right. So I can say that total solidification time for cylinder is proportional to what is the volume. I got a volume is equal to pi h cube and area is equal to 4 pi h square. So that is pi h cube by 4 pi h square. That is a square. So can I say that my total solidification time for a cylinder is actually proportional to h square by 16? Now see here, total solidification time for a cube. What is this? This would be proportional to volume of cube by area of cube whole square. Now see, total solidification time of cube would be proportional to volume of cube. What is this volume of cube? 8h cube. Area is 24h square. So can I say that 8h cube by 24h square whole square? Clear? So this is given to you. So you can say here total solidification time for cube is proportional to h square. H get cancelled here from your turn. Yeah. H square by 9. Clear? So you are getting h square by 9. Okay, so you are getting h square by 9. Now you know these things, right? And in this question, it has been asked to find the ratio, right? It has been asked to find the ratio. So you just to find the ratio, right? Just find the ratio, take it out. Let this be equation 1, let this be to be equation 2. So total solidification time for cylinder by total solidification time for a cube, that is nothing but h square by 16 by 9 by h square, that is 9 by 16. So if you calculate it, you will be getting something like, that is 0.5625, 0.5625. So my answer is 0.5625. Okay, now based upon the answer, suppose in this answer it has been given to round off of the two decimal places, so round it, so my answer will be nearly is equal to 0.56. Clear? Yes, Ashish and Shiv Kumar both has given correct answer. Okay, समझ में आ रहा है everyone, whosoever is watching, understanding how the questions are asked in gate? Very easy questions are asked, but you have to be very much focused about these questions. hmm. चलिए, इस क्वेश्चन का आंसर बताइए. Just now we have seen that two streams of liquid metal which are not enough to fuse properly result in the casting defect known as. Tell me the answer. Tell me the answer of this. We have seen just now the casting. Hmm? Just now we have seen this casting. Tell me the answer. No, show the slide of the question. Which slide? After the video, once the video is over, you can take these things. Now solve this. That is actually cold shut. Okay, we have seen these things. That is cold shut. Okay, है ना? Just now we have seen these things. What is in this cold shut? Two stream of liquid is passing, right? And they are not actually efficient to fuse properly, right? So they cannot fuse properly, not fuse properly. We have seen these things, right? So these are the questions that are actually asked in the gate. Okay, now try to solve this question. Now try to solve this question. Very easy question is there. I'm giving you 1 minute time, and after that I will solve the question. Yes, Shiv Kumar and Sis has given correct answer. Try to solve this question and tell me the answer. Try to solve it. See, this question is a very simple question. This question is a very simple question. You have to understand it. The figure shows a pouring arrangement for casting of a metal block. Frictional losses are negligible. The acceleration due to gravity is 9.81 meter per second square. The time to fill up. Now, first of all, you have to see here that this is my volume of the mold cavity. This is my volume of the mold cavity, and this is the pouring basin, and this is the riser, right? So, if I would ask you, is this a case of a top gate or a bottom gate? Can you tell me? Is this a case of a top gate or a bottom gate? Very fast, tell me, is this a case of a top gate or a bottom gate? Tell me in this figure that is given to you, is this a case of a top gate or a bottom gate? So here actually the filling height is given. What is the filling height? That is 220. Clear. The filling height is given as 20 centimeter. Let me write it here. Filling height, that is, let us assume this to be ht, is equal to 20 centimeter. Tell me, is this a question of a top gate or a bottom gate? क्या दिख रहा है यहाँ पे? At least reply me. Filling height is given ht is equal to 20 centimeter. Now we can see here that diameter of gate, right? See, diameter of gate is given as 2 centimeter. Diameter is gate of given as dia of gate. Let us assume dia of gate dg to be 2 centimeter. Okay, that is 20, that is let to be 0.2 meter. So now dia of gate is given, filling height is given. Clear. Now volume of mold, this is the size of mold that has been given. So if I will calculate volume of mold, that is Vm, right? So what is the value of Vm? Vm would be 0.4, 40 centimeter, let it be 0.4, 15 into 30, so let it be 0.3 into 1.5. This would be is equal to 4, 3, 12, 12, 15. So this is going to be is equal to 0.018 meter cube. So this is the volume of a mold. Clear. So this here the volume of mold is given. And see here the diameter of gate is given. So now since this is a question of Asis and Shiv Kumar has given top gate. Yes, since this is a question of top gate, so I know that time taken to fill the mold is given by, in case of a top gate, that is Tm is given by what? That is Vm by Ag into root over of 2g ht. Clear. So these things have been known to us. Now see, Vm I know. What is Ag? Ag will be what? Pi by 4 into dg square, diameter of gate. See, diameter of gate is given. Ht you know, just you have to put these things in this figure. So let me calculate. Tm is equal to Vm. What is this Vm? 0.018. So let it to be 0.018 meter cube. Now you know that pi by 4 into 0.02 whole square, that is dg. See, dg is given as 0.02, so you can find the ag, that is pi by 4 dg square. So you are known to this. Now see, ht you know as zero point 0.2 meters, root over 2 into g into zero point 0.2. So from here you can calculate root over of 2 into 9.81 into zero point 0.2. Clear? So after calculating this, you will be getting a value to be. So you are getting the value as 28.92 seconds. Okay. So this is the answer that you are getting for time, filling time. Clear? Filling time. ठीक है. तो ये जो है बहुत ही सिंपल क्वेश्चंस आया था गेट 2019 में. Yeah. Try to see these things and you will be able to solve the questions. Okay. कोई डाउट तो होगा नहीं. If you have any doubt, then please do let me know. Now see here, there is another questions. You just watch how I am solving these things, and so that we can save some lot of time. Okay, now see here, the shape factor for a casting in the form of annular cylinder. Annular cylinder means what? That is having outside diameter and inside diameter. Clear? So there is an annular cylinder. So let me draw the annular cylinder like this. This annular cylinder, this diameter, okay, so let this diameter is di and let this to be do. Okay, let this to be a do, diameter to be do. Clear? Now see here, I know do to be 30. See, 30 centimeter is given, and this di to be 20. Clear? So this is 20, this is 20. Now see, this length, diameter and inside is given and height is given as 30 centimeters. So can I say this length to be 30 centimeters? What is being asked? Shape factor for a casting in the form of an annular cylinder. So suppose that if you have been given an annular cylinder, how you can calculate the shape factor? So first of all, first thing that you should keep in your mind, that is here, that is given that diameter, outer diameter is 30 centimeter, inner diameter is 20 centimeter. Clear? And length is given as 30 centimeter. 30 centimeter. Now what is the shape factor? How you can calculate the shape factor? How you can calculate the shape factor, that is SF. So you can calculate the shape factor as length plus width by thickness. Clear? Now see, I can also write it as L plus W by T. L plus W by T. Now see how you can calculate. You know the length, right? But you don't know the width and you don't know the thickness. Now to find the width and the thickness of this kind of annular cylinder, you must can convert. See, you have got like this, right? You have got a annular cylinder, right? So you have got the annular cylinder. So just assume this to be a like a full cylinder. Okay, solid cylinder, assume this to be a solid cylinder. So here it will have a diameter, that is mean dia. Clear? So that is mean dia. So from by with respect to it, you have to calculate the width. What is the width? Width is defined as pi d mean. Okay, pi d mean. What is the mean diameter in case of this annular? So can I say that mean diameter in this case would be nothing but outer diameter plus inner diameter by 2. This is the here, that in this case. Now see, width will be pi outer plus inner. Outer and inner is what? 30 and 20. So can I write like that? That this would be pi into 30 plus 20 by 2. Clear? So from here, when you will calculate it, this will be 50 by 2, that is 25, 25 pi. So 25 pi you have to calculate it, and you will get answer as 78.53. Clear? So 78.53 centimeter. So this is the width that you are getting. Now see, you are getting the width as 78.53 centimeter. Now from here, you know that what would be the thickness. See, this is my thickness, this is my thickness, right? Now see how you can calculate the thickness. So you can calculate the thickness t. How you can calculate thickness? Thickness is equal to d outer minus d inner by 2. So what is d outer? 30 minus of 20 by 2. See, this is the thickness, this is the thickness. So this t would be is equal to 10 by 2, that is a 5. So 5 centimeter. You know already this L is 30 centimeter. So this L is known to you. This L is equal to 30 centimeters known to you. Now you are knowing L, you are knowing W, you are knowing T. So very easy to calculate the shape factor. Now shape factor is equal to L plus W by T, right? So what is my L? What is my L? L is 30 centimeter. So can I write 30 centimeter? Width is 78.53. I will write 78.53 centimeter, and thickness which I have calculated is 5 centimeter. So I will write here as 5 centimeter, and hence I will calculate it in the answer. So let me calculate it down. That is coming around 27.70. Clear? So I have a shape factor of 27.770 is there. So I can easily say the answer would be A. Any doubt? Any doubt? Any doubt, sir? These questions are very good questions, good quality questions are there, sir. Very concepts would be clear, a lot of concepts will be clear from these questions. So I hope you don't have any doubt. And if you have any doubt, then do let me know. Okay, so let us see this question. Let us see this another questions that has been asked in GATE 2015. See what is asked in this question. A cast steel slab of dimension which is given as 30 cross 20 cross 5. Clear? There is a cast steel slab which has a dimension of 30 cross 20 cross 5. So I will write it here. Cast steel slab is there whose dimension is given as 30 cross 20 cross 5. Clear? Now see, is poured horizontally using a side riser. Fine. The riser is cylindrical in shape with diameter and height both equal to d. So here it is given as diameter is equal to height, both is equal to equal. The freezing ratio. See my dear friends, in this question, freezing ratio has been asked, right? Freezing ratio has been asked. So what is the freezing ratio? What is this freezing ratio? So can I say that freezing ratio is equal to V by A of riser by V by A of casting? Clear? Now see, what is this V by A of riser? Is it modulus of riser? And what is this casting? Is it modulus of casting? So can I say that my freezing ratio, let this freezing ratio to be Fr. So my Fr is nothing but modulus of riser by modulus of casting. Clear? Okay. So you don't have any doubt. So these things are there. The freezing ratio is equal to modulus by riser by modulus of casting. So now what is the next step that you have to do? Just to find the modulus of riser and modulus of casting, and just divide it, and you will get the freezing ratio. So now see, let us calculate for the casting. So let us calculate for the casting. Okay. So for a casting, modulus of casting is equal to V by A. What is volume of a casting? See, 30 into 20 into 5 is given. Clear? This is the dimension. So this would be my volume. That is 30 into 20 into 5. Now this is surface area. So the surface area will be what? Twice into 30 into 20 plus 20 into 5 plus 5 into 30, isn't it? Now if we will calculate it from here, let me calculate it down. So you are getting 30 by 17, which is actually is equal to 1.76. So you have found the modulus of casting. Now let us find the riser. Okay, modulus of riser. So what is this modulus of riser? That would be equal to V by A. Now what is the volume of the riser? Can you say that? That is 5 by 4 d square into h. Okay, now see what is the surface area. You know that that is equal to twice into pi by 4 d square plus pi dh. Right, now we know that here it is given that d is equal to h. So I will just put it here, d is equal to h. So we know that pi by 4 d cube pi by 2 d square plus pi d square is equal to pi by 4 d cube by 3 by 2 pi d square, and hence we are getting d by 6. We also know that for a riser to be cylinder, modulus is d by 6, right? So either you can remember these things, or if you cannot remember these things, you can always uh, do with these process and you can always get the answer. So this is my d by 6. So modulus of riser would be nothing but d by 6, right? So what is this d by 6? Now see here, now see here. So this is my riser. So freezing ratio I have to calculate it. So how I can calculate the freezing ratio? So freezing ratio I can calculate it by modulus of riser by modulus of casting. What is the modulus of riser? This is d by 6, d by 6 into 17 by 30. See, this is the 30 by 17 was there. So if you will calculate it, you will get 17d by 180, which is something around 0.094d, right? So which is approximately 8d by 75. So from here you can say my answer is 8d by 75. Clear? 8d by 75. So I hope this question is clear to you. Now see this question. See this question. In this question, it is given the schematic diagram of pouring basin and a sprue of a gating system is shown in this figure. Depth of the molten metal in the pouring basin is given as 100 mm and the height of the sprue is 1500 meter. So this is the height of the sprue. Clear? So this is the height of a sprue and this is the 100 mm given. So can I say that depth of pouring basin, right? Depth of pouring basin, that is HB, is equal to 100 mm. Clear? This is given 100 mm. Now see, I can also see that height of a sprue, this is the height of a sprue, is given as 1500. So height of a sprue, that is HS, is given as 1500 mm. Next, what we can say, what is the total height? This is 100, this is 1500. So can I say that total height, that is HT, is given as HB plus HS, which is nothing but 1600 mm. Clear? Now see, in this question it has been asked, considering the cross section of the sprue is circular, ratio of d1 by d2. So ratio of d1 by d2 you have to calculate to avoid aspiration, right? So we know that condition of aspiration, condition of condition to avoid, right? So condition to avoid aspiration effect. So what we can see here, see, if I will use the a1 1 point to be this and this to be 0.2, so that would be a1 by a2 would be is equal to root over of total height ht minus of hs by ht. So I have derived this equation in the while I was explaining you about the aspiration effect. So if you cannot remember this formula, just check those things, just check those formulas what I have written you. So that would be like this. Okay, so now from here you can say that a1 by a2 is equal to root over of ht minus hs by ht. So what is this ht? 1600. What is this hs? 1500. So you can calculate it here. And here in place of this, what you can write here? You can write here as pi by 4 d1 square, pi by 4 d2 square, root over of ht, that is 1600 minus of 1500 by ht is 1600. Clear? Now from here you what are the things that you are getting? This is root over of 100 by 1600. Clear? This is these two things are going to be get cancelled out. Okay, so we are left with only and only d1 square by d2 square is equal to root over of 100, that is 001 by 16. Clear? So let me write it here, that I am getting as d1 square by d2 square is equal to root over of 1 by 16. So now if you will calculate it, you will be getting answer as 1 by 4. See, this is root over 1 by 16. This is going to be is equal to d1 square by d2 square is equal to 1 by 4. Again, what you have to calculate, d1 by d2 is equal to root over of 1 by 4, and hence you are getting as d1 by d2 is equal to 1 by 2. So from here I can say that d1 is to d2 is equal to 1 is to 2. Clear? And from here you have got the option as D. Okay, you have got the option as D. So d1 is to d2 ratio is 1 by 2. Any doubt till now? Any doubt till now? Please just give me at least replies that you don't have any doubt. Okay, so I'm assuming that you don't have any kind of doubts. Okay, so let us try to solve this question. At least try to solve this question and give me the answer. Try to solve this question and give me the answer. Try to tell the answer. Very easy question is there. This question is also very easy. See here, see here. What is the function of a sprue? What is the function of a sprue? So function of a sprue is what? Feeds the molten metal from pouring basin to the gate. Right? Pouring basin to gate. Right? So this is my pouring basin, and this was my sprue. Right? So this is my sprue. These things we have seen. And see, whatever the molten metal was here, so molten metal is poured from here with the sprue. So it feeds the molten metal from pouring basin to gate. Okay, to gate, and after the gate it is to the casting. Clear? So the spruce function is 2. So in which option there is a 2? So this is cancelled out. This is correct. This can be correct. This is cancelled out. Clear? Next is what? What is this riser? What is the use of this riser? We know that riser is supplies the molten metal to compensate for a liquid sinkage. We know. So Q is 4. So again in this also Q is 4 and also the Q is 4. Now what? Let us see the pouring basin. Let us see about the pouring basin. So pouring basin is what? It acts as a reservoir for the molten metal, right? So S3. So S3 is in this. Only and only this option is correct. So option B is correct. Clear? Option B is correct. Now see here. Try to solve this question and tell me the answer. Try to solve this question and tell me the answer. Tell me the answer of this question. Tell me the answer. Yes, Asif. Asif has correctly said answer. Tell me the answer of this question. No one is giving the answer. See, I have already explained this question in my subsequent previous lectures, that carbon dioxide molding process, this was actually a process in which we are using the sodium silicate, right? So I have told you there is a sodium silicate casting. Okay, so sodium silicate casting, I have told you. In this I was I have told you regarding the self and the carbon dioxide molding, right? So in this carbon dioxide molding process, binders used is sodium silicate. Yeah, so this is the things. So I have tried to complete almost everything in this casting. I have also covered a lot of numericals here, right? A lot of numericals. Hope these all things are very much clear to you. And if these things, if these all numericals, whatever I have done throughout these lectures, if these things are clear to you, then and theory and numericals both are very much important for this casting. So let me again tell you, theories and numericals are very much important for casting. So theory plus numerical, both you have to do it, both. So you cannot rely on only numerical or you cannot rely on only theory. You have to do both of the things in the casting. So I have tried to incorporate almost everything in the here. So thank you so much. If you have any doubt, then you can ask with me. And if you are going for a plus subscription, if you are planning to purchase a plus subscription, you can always use my code SIRVK, SIRVK, as the prices of the uh, plus subscription is going to increase, and hence you should purchase if you are planning for the per plus subscription. Okay, so this is my code SIRVK. You can always follow me at the rate of v.ksir in the Unacademy app, so that whenever I will take the classes, you will be getting notified. And tomorrow also I will have a class of strength of material in the Unacademy app at 11 o'clock, 11 a.m. And one more announcement is that from 5th of October, I will be taking classes in night in night, and the timing would be 10 p.m. to 11 p.m. Only 1 hour classes would be there from 5th October. I have already told you there will be a classes at 11 a.m. Strength of material. This is PM and this is AM. Okay, this is in the morning and this is will be in the night. Morning and night. Manufacturing would be at this slot. Okay, so if you have any doubt then please ask with me. 8:45 जो होगा ना वो 4 तारीख तक 8:45 में ही क्लास होगा, लेकिन फ्रॉम 5th of October आई विल बी टेकिंग क्लास at 10 p.m. I have written from 5th of October. Okay, 5th October. Yes, for production. Any doubt you have then please ask with me. From 5th October प्रोडक्शन क्लासेस जो होंगी वो आपका 10 बजे से लेकर के 11 बजे रात में होगा 5th October से, मतलब कल 8:45 में ही होगा, परसों से आपका 10 से 11 हो जाएगा टाइमिंग, और मॉर्निंग में 11 AM में मैं स्ट्रेंथ ऑफ मेटल पढ़ाऊंगा आपको. एनी डाउट यू हैव देन प्लीज आस्क विद मी. एंड I cannot see that doubt that has been asked by Subham, I think. So from tomorrow onwards the topic would be welding. Okay, so I will be teaching you welding. So if you have any doubt then please tell me. और शुभम जी का वो जो डाउट उन्होंने पूछा था वो डाउट मुझे अभी मिल नहीं रहा है in the comment box so that I could reply to him. चैट बॉक्स में मुझे दिख नहीं रहा उनका डाउट. Okay, so I think you have got benefited with this video. If you really got benefit from this video, you have understood everything from this video, and you are getting advantages. Your concepts are actually getting built up. You are getting some confidence from these videos. Do like this video, share this video with your friend circles, and if in your friend circle and in your peer circles, and if you are planning for a plus subscription, use my code SIRVK, SIRVK, and you will get a 10% off, as well as I will provide my mentorship to you. Share this video to the persons who are actually in need to understand the manufacturing, so that you will be getting benefited as well as they will be getting benefited. So share and learn. So thank you so much for your active participations, and thank you so much. So I'm ending this session. I have tried to. Why aspiration effect leads to erosion, sir? एस्पिरेशन इफेक्ट के कारण क्या होता है ना, इरोजन जो है, देखिए एरिया में चेंजेस होते हैं, ठीक है, एरिया में चेंजेस होते हैं और इसलिए आपका इरोजन होता है, ठीक है, यही रीजन है, ठीक है. उनका एग्जैक्ट क्वेश्चंस मुझे मिल नहीं रहा, आई डोंट नो, बट if that is the questions, there is a change in the area and hence the aspiration, there is a erosion. Okay, so thank you so much for your active participations, and yes, do like this channel, and like this video, subscribe this channel, so that whenever I will be posting any videos you will be getting notified. You can always follow me in the Unacademy app at the rate of v.ksir, as at the rate of v.ksir. You can always follow me. I'm posting the videos for strength of material there, and tomorrow would be the module 3, last session of the module 3. I will be starting the next chapter, that is the bending of stress. If you want, you can join my strength of material classes. So thank you so much.